Hello, welcome back to the Richardson Lectures on the challenge of resource management. This time we'll be talking about changing energy resources in the UK. You need to be able to describe and explain the changing energy mix in the UK, to explain the impacts of different energy sources, and also evaluate the use of fracking as a source of energy in the UK. First of all then, the demand for energy. Well, actually, unlike the other resources we've seen in previous videos, the consumption of electricity has actually decreased in the UK in recent years, and that's due to two main reasons. First of all, a decline of the heavy industries in this country, which were very energy intensive, but also an improved energy conservation, the use of low energy appliances, and also better insulation in our buildings, meaning less energy is being used there. In fact, actually, it's the source of energy which has changed in this country, and that's also its biggest challenge. When we talk about sources of energy, there are two main types, renewable and non-renewable. In the UK, we use both renewable and non-renewable, but it's the non-renewables that form the largest part of our energy mix. So non-renewables, these are the sources of energy that are actually running out, and that's because they take millions of years to form. They mostly consist of fossil fuels. These are organic fuels such as coal, oil, natural gas, that are formed from the remains of dead organisms. So coal, for example, there's lots of coal in Yorkshire, and that coal formed around 300 million years ago, 300 to 350 million years ago in what's known as the Carboniferous period. At that time, Yorkshire was dominated by swamps, and in that swampy environment there were lots of trees. Trees take, of course, carbon dioxide in from the atmosphere, and that becomes part of their structure. When those trees died, they fell into the swamps, and because they're in that anoxic environment, the trees didn't break down, they were preserved in that water. And over time, sediment was buried on top of them, and more trees fell, and you had layers upon layers of these dead trees that were being preserved in that anoxic environment. And over time, the compression turned those deposits into coal, which we then now extract and burn as a source of energy. Nuclear energy is also non-renewable, because the uranium that's used won't actually last forever, even though only very small amounts of uranium are used in the nuclear energy production. Now, as well as running out and not having enough energy for our energy supply and our energy security, another big worry is that burning fossil fuels creates a lot of carbon dioxide, which then goes into the atmosphere and is, of course, a very prominent greenhouse gas that causes climate change. And that's because the carbon that's been taken by those trees 300 and 350 million years ago into their bodies and stored underground has been underground a long time. But by us extracting that coal and burning it, we're putting that very old carbon back into the atmosphere and leading to climate change. Now, the other option is renewable sources of energy, and these are sources of energy that they're readily available from natural processes. Most of them are very, very clean because they're just using those natural processes, such as wind and solar power. So wind turbines turning to create in the wind to create energy, solar panels taking energy from the sun, hydroelectric, where we're using the power of water, often using dams and reservoirs, and water moving through a dam can turn turbines to create energy. And geothermal. Geothermal involves using the natural heat of the earth in tectonically active areas to create steam, which can then turn turbines and again create electricity. So that's obviously very common in areas that are tectonically active. Iceland, a really good example of somewhere that makes good use of geothermal energy. So let's have a look at the UK's energy mix. The energy mix is the range of energy sources used in a particular region or country. We're going to look at the UK's. And here I've got three pie charts that show the changing energy mix of the UK between 1990 and 2014. Now, what we can see, we'll take a look at 1990 first of all, dominated by coal. And coal, as you'll see, is common, the green colour, in all three of these pie charts, but it's 1990 when it forms a very large proportion, around 65% of the UK's energy in 1990 coming from coal. And that has decreased since, but in by 2014, still around a third of our energy coming from coal. Oil only featured in 1990. The use of oil as an energy source disappears by the time we get to the 2000s. Gas, something that's very minimal in 1990 but becomes very common in the 2000s, but then is starting to shrink. And that the shrinking in 2014 is actually a result of the expansion of renewables. So we can see renewables from a very small amount of our energy mix in the 1990s and the early 2000s, but by the time we get to 2014, renewables forming around 15% of our energy use, and now is even more as we're pushing towards making more use of those renewable sources. And one of the main reasons for that is because it's a cleaner source of energy, so it's, of course, renewables not contributing towards global warming, but also they're not going to run out, they're renewable. So the coal, we know the coal and the oil and the gas is running out, and so we're seeing that slow shift towards renewable sources. However, we've still got a big reliance on coal, although most of that coal actually in the UK is being imported, because imports are cheap, mainly from places such as Russia, USA, and Australia. It's remarkable, it's actually cheaper to import coal from abroad than actually get it out of the ground in this country. So we still do have plenty of coal in this country. It's just not economically viable to extract because of the higher now costs of labour, the health and safety involved. To extract some of this coal, it's actually still cheaper to pay to have it imported from abroad and buy it in than extract our own coal as a result of those costs. So let's take a look at a couple of other methods of energy production and look at some of the kind of weaknesses of those as well. Because fossil fuels are running out, we are seeing a shift towards other types of energy sources such as nuclear and wind power. We'll just look at those two now. So nuclear power, that involves using these power stations where nuclear reactions in the power stations generate heat, which can then be used to heat water to create steam, which then can turn turbines to create our energy. And these were particularly very popular at one time, but we're seeing the kind of decline in the interest in them now because of these limitations. First of all, they're incredibly expensive to build. And then one of the biggest risks is actually trying to store the highly toxic and radioactive waste that was generated as a result of producing the energy. And so there's a risk of leaks from that, significant health impacts for people and the environment. And also the warm water waste that's coming from the nuclear power stations can often harm local ecosystems. So in terms of an environmental point of view, and also economic with the expense there, we're not as interested in nuclear as we once were. One thing that is becoming increasingly popular though are wind farms. This is where you've got your large turbines that stand either on the land surface or out at sea, and as they turn in the wind, they're generating energy. Now, we do see quite a lot of these out and about in the countryside, but we see an increasing number of them forming offshore. Personally, I think that's probably one of the best places for them in terms of reducing the impacts on the land and using some of the seas around the UK to produce wind power. Now, obviously, one of the main limitations is they're only producing energy when the wind is blowing. Now, when you're burning coal, as long as you've got that supply coming out of the ground, we're still burning, we're still creating energy. If we're just relying on renewables such as wind turbines, if the wind's not blowing, we're not creating energy. So there's a bit of a potential risk there. We couldn't solely rely on wind power. There's a high visual impact on the landscape. A lot of local people don't like them. Tourists often don't like them. And they also create a lot of noise, surprisingly noisy machines when you're close to them. Again, causing upset to the kind of local populations. So another solution to our ensuring energy supplies for the future is to consider fracking. Now, as I said, we are importing a lot of our non-renewable source of energy at the moment in the UK, and fracking would be an opportunity to reduce that reliance on imports and actually have our own supply of fossil fuels. It would give us greater energy security. Now, fracking, or hydraulic fracturing as it's formally known, is a method used to extract shale gas. Shale is a very fine-grained mudstone, and within that we find a natural gas, a shale gas, which can be burnt as a fossil fuel to produce energy. And we can extract that using this process of fracking. It's rather controversial though. Now the process, you can see by this diagram here, involves drilling down into shale rock. So the drills are sent down through the bedrock into the shale layer. It can then the drill bits now can be turned horizontally and they can move through the layer of rock. And once you've created that passage, what happens then is water and chemicals, and often sand as well, pumped at high pressure down those wells, which causes the surrounding shale rock to fracture, hence the fracking. It cracks the rock and allows the gas to escape, and then the gas can be drawn up through the well. Now, the fracking in the UK has actually been met by a lot of resistance. It's a very topical issue. There's a lot of people resisting it. They're concerned about a number of things. First of all, the risk of earthquakes. We have already seen in some sample fracking over in Lancashire, it's actually led to, or said to have led to, some minor earthquake tremors. So obviously there's a risk there of kind of structural damage. There's a big risk of contamination of groundwater. That's quite widely reported in America, where if you're having the shale gas escaping and getting into the local water supply, people then drawing that water up from wells and drinking it while it's containing gas. And there's even been some extraordinary scenes you can see elsewhere online where people can actually set fire to the water coming out of their taps because there's that much gas coming through it. It is rather expensive, even though it will provide, of course, lots of jobs in the UK, so there is a benefit there economically. But to me, the biggest issue is that it's not a clean source of energy, and it's very backwards to me to be thinking we should be investing in something that is effectively another fossil fuel, another big contributor towards climate change. It seems very backwards to me that we'd be investing in this type of energy production when actually we could be investing in further expanding our wind and hydroelectric and solar panel use across the UK. So finally, we'll finish off with some short exam questions today about energy use in the UK. So here's the first one. We've been given figure 11, a graph showing source of energy used to generate electricity in the UK between 1985 and 2015. So we can see there we've got coal, gas, oil, nuclear and renewables. And the question says use figure 11 is to complete the paragraph below. So it's a gap fill for 3 marks. So a lot of marks available for a relatively straightforward question. We just need to use the data to help us complete these gaps. So we've been given the options here in bold. So the first sentence says the supply of electricity between 1985 and 2015. So we're after talking about the trend here. So what's happened? Well, they come in pairs really, these words. What we're looking at is it fluctuated or remained steady? Well, we can see that electricity, the supply has been very varied over that time. So that has actually fluctuated significantly over time, fluctuating meaning it going up and down. In 1985, something was the main source used to generate electricity, supplying over 60%. Well, we can look at 1985. What was the main source? It's the red dotted line. It's coal, so the second one is coal. And then by 2015, gas had become the number one source used to generate electricity. The rapid increase in the use of gas having started when? And we're really now looking at 1992 or 1989. Well, we can see the black line is gas. There's the sharp increase here. 1985, 1995, so 1990 is in the middle. We're after 1990 when it starts to increase, so the answer is going to be 1992. Okay? So just work your way through these kind of questions logically. Make sure it fits. Double check. Try both answers if you need to. Potentially very easy marks in the exam if you just take a little bit of care to make sure you get these right. And then question 2, give 2 reasons why the use of coal decreased between 1985 and 2015. Well, there's a number of reasons. The mark scheme did actually like to get away with one developed point. I think that's because some of these points can be quite similar. But really, we should be able to make 2 statements here. We could talk about the kind of the relative price, and that the relative price of coal has increased as a result of that. We're using a bit less of it. But the main ones really are the fact that coal is running out. That's one of the main reasons why it's decreased. But also, and that's linked to government policy. So quite famously, British Prime Minister Margaret Thatcher closed a lot of coal mines during her period of power, and so we saw a decrease in the use of British coal. But also, of course, there's concerns about the environment and trying to move towards renewables. You could have also commented on that kind of international carbon agreements, meaning we're trying to reduce the amount of coal being used. And then lastly, we've got figure 9 here. It's a map showing world oil consumption in 2016. And the question says, what is the difference between Africa and North America's share of world oil consumption shown in figure 9? So for each continent, we can see we've got these little squares on them, and each one of these squares represents 1% of world oil consumption. Well, we count them up, we can see Africa's got 4% of the world's oil consumption. North America has actually got 24%. So the difference is going to be 20%, or you could also reword that as being 6 times greater in North America than in Africa. Another 1 mark. Okay, so that's it for this video. The next series of videos are going to focus on food resources globally, and we'll start by looking at the distribution of food resources.